Hey, this is Pat Martin back again with another Dex demo, and this week what we're going to cover is going to be the Steam Graph view. And I'm going to start off here with a artificial data set that we create on the fly. It's just a random data set. First thing we're going to do here is include the random number generator and initialize that, and then we define three parameters for the number of columns, number of samples or rows, and the amplitude of each random value. Next, we're going to create the header, x plus all the other columns dictated by this num column variable, and we initialize our data to be empty, and then we just loop over the number of samples or rows, and we create each column in turn and append it to the overall data, and then the data, the header, get returned back to Dex. And then what's going to happen here is when I execute, it's going to create a row or a column called X. It's going to vary from 1 to however many samples we had there. Looks like we had 1,000. Let's change this to be a little bit less than 1,000. Let's go with 100, and let's go with maybe 5 columns. I'm going to re-execute this, and now we see that those changes have taken effect. It's a really nice way to put a quick and dirty data set together and to be able to drive the test behavior of what we're going to be looking at next, which is going to be the Steam graph. So every time I execute, we're going to see that different data set comes through. And now I'm going to go over some of the capabilities of the visual. So if you hover over any of the parameters, it describes what they are. Some of them are pretty obvious. We have the height, make it taller, shorter, whatever. Make it wider. And we also have opacity, which makes it transparent, where we can't even see it, or fully opaque. And next we have the stroke width, which is kind of surprising when I first saw this. It looks almost like a cartoon or art, and I'm going to just make that a stroke width of 1. We can also, or actually let me exaggerate that a little bit, we can also change the stroke color, change that to green, gray, or you can also use these types of ways to denote the colors for red, but I tend to use the mnemonics, so I'm going to change that back to black, change the stroke width back to 1 here. And next we can also size the data in different ways. So this is just a linear sizing based on the value at that particular column and row. So change this over to square root. We see it modify the graph somewhat. Change it to the power. Quantize, not sure if that makes sense here, and just identity, and I don't think threshold's going to work, but it didn't. Not to be disappointed. Okay, so next is the offset. So this changes the way the data is also laid out. So this is the default wiggle view, and change over to silhouette. We can change to expand, which is going to use the entire space of the SVG. And then last but not least, we have a zero base that's going to, it's almost like an area chart. And next we can also change the colors. So I'm going to change this back to silhouette, and let's just cycle through the colors real quick. So that's one of the category 20 color map. 20B, 20C, yellow green. So these are the color brewer colors, and that's really pretty. Cycle through these so you can see them all real quick. And then we are going to get to the color map I made, which is pretty ugly, but the reason I designed this color map is because I wanted extreme differences between colors, so I could easily tell one point from another. And then we also have the soft separation and the hard separation. Let's see, last but and probably least as well, we can add a title. And that's it for that data. I'm gonna push the envelope a little bit here. So that was just a little bit of data. Let's take a look at a lot of data. So let's say we have 20 columns, and let's bump it up to maybe 1,000 samples. So what's that going to look like? Kind of like a pretty rainbow here. So I'm going to increase the width. Well, it's too far. And also something I failed to mention is you can also hover over any of the areas, and it'll tell you what that path is. C20. These are not exactly great names for the columns, but since it's an artificial data set, it's good enough. It's good for testing. Next, and what I also want to show is any graph, any D3 graph can also be visualized through the WebDriver. And this is important because what this means is that when you have your own copy of Dex, you can also create your own templates. So you can basically create your own custom views into Dex. So you basically have the ability to define your own components. Now another nice thing about this is that what I'm going to do is I'm going to enable this and disable that, re-execute, and what I'm going to see is that Chrome is going to pop up pretty much the same view we had before. But what's nice also is that we can go to the tools here, and we can do things like debug the code. We can take a look at specific elements within the chart. So this is a really useful feature if you're creating your own views into this. And another really nice thing is the fact that Chrome tends to be slightly faster than the WebKit browser that comes with JavaFX. So I'm finding I'm spending a lot more time in the code browsing mode than I am in the JavaFX browser right now. So hopefully that's going to change, because the 64-bit version of that, which is what I'm running, is a little slower than the 32-bit. So I think that's going to shift over time. So next, what I want to do is I'm going to disable this, and we'll keep the view going here. And I'm going to enable this GC data. So this is just one of my litmus data sets, and what I'm trying to show is that we can easily read numeric data from a data source. We can do that right here, and what we see is this data set that I had on disk has been visualized into the Chrome browser. It's not much to look at, but it makes the basic point. So last but not least, I'm going to enable this guy, disable him. I'm going to add a row number, and let me also enable the football filter. So let me go with, I'm going to keep institution name in there so we can see that, and I'm going to execute, and what we can see here is that we have a row index that's going to be used for the x-axis, and then we have a score for, score against. So basically this is a whole lot of football teams and the scores across the season for the home team versus the opposing team. And it looks like this. Nothing too exciting. There's only 2 series here, but I was kind of surprised to see that this one little effect here. So when I let me change this to 0. So when I did that, it looks almost like a landscape, and or not a landscape, but like a cityscape. And I'm always surprised when data almost becomes art itself. It's fascinating. So anyway, I think that's about all I had to show. Maybe I'll do one more thing real quick. So before I go here, so let's push the envelope in a big way on this. So let me disable this and let's go back to the data generation, enable this, and I don't know, instead of 20 columns, let's go with 50 columns, and instead of 1,000 samples, let's go with 2,000. So this is going to essentially be 100,000 pieces of data, actually, and then some. So let's see what that looks like. I have no idea. It looks pretty much like the last one, only a little bit more busy. But this is actually a pretty well performing visual for 100,000 points of data. You know, that's really not too bad. Let's play around with this just a little bit. So what I'm going to do is I'm going to put this even a stroke width of 1 dominates the screen. So what I'm going to do is I'm going to write this up in a blog entry. I'm going to post the video here, and I'll put some live versions of these visuals. In fact, I'll go ahead and save them off and post them to the blog. And that's it for now. Thanks a lot.